All right, we're going to look at Appendix E, which is on sigma notation, because this gets used a good bit in Chapter 5. So sigma notation is just a way that we can write sums out in a compact manner. So we've got the capital sigma over here, and around it we've got several things. On the bottom, this I is called the index, and this tells us where to start. So the index, let me write that legibly, the index is I. And it starts at 1. Most of the time that when we do this, the index is going to start at 1, or maybe it'll start at 0. Occasionally it'll start at something else, but usually it'll be 1 or 0. The number on top tells you where to stop, or the highest value. For I. And then this is a function that tells you what to plug I into. If you're into computer programming at all, it's a lot like a for loop, where you say for I starts at 1, goes up to n, and we evaluate this function for each value of I, then add those together. So for instance, on this example here, I squared, we're starting at 1, so this is going to be 1 squared plus 2 squared plus 3 squared plus 4 squared. We stop at 4. So let's see, what is that? That's 1 plus 4 plus 9 plus 16. Just add that up, you get 30. All right, another example. We're going to go from 1 to 5, and on this one, we're adding up 1 over I. So on this one, the first thing is going to be 1 over 1, then plus a half, plus a third, plus a fourth, plus a fifth, and we'll add that up and see what we get there. Now we could get a common denominator, or we could take the easy way out and stick it in a calculator that'll do fractions. So 1 plus a half, plus a third, plus a fourth, plus a fifth, 137 over 60. All right. Let's see, this one down here. Notice this negative 1 raised to the n power. What that does is it makes the series alternate, or the terms are going to alternate. So when I is 1, we get negative 1 to the first power times 1 over 1. Then we get negative 1 to the second power times 1 over 2. Plus negative 1 to the third power times 1/3, negative 1 to the fourth power times 1/4, plus negative 1 to the fifth power times 1/5. Now that was actually a lot of stuff to write out, but really what this is doing, the odd ones are negative and the even ones are going to be positive. So what this gives us is negative 1 plus a half minus a third plus a fourth minus a fifth. So that negative 1 raised to a power is an easy way to make it alternate. So let's see, what's this add up to? Negative 1 plus a half minus a third plus a fourth minus a fifth. That gives me negative 13 over 12. All right, now we got a couple of examples here where we're going the other direction. We're trying to write this using sigma notation. Okay, so this one, if you look at what's going on here, we've got, this is the number that's increasing every time, so that's going to be our I. And then we're raising all these to the fifth power, and I starts at 2, and I ends at 5. All right, this one down here, this one is a little different. On each one of these, notice what's going on. The denominator is always one more than the numerator. So I would write this as I plus 1 and I on top. And let's see, I starts at 3 and goes up to, see, it starts at 3 and it goes up to 9. Now that's not the only way you could do this. You could write it as, you could make the bottom of this thing I, and the top of it be I minus 1. And if you did that, then your I would have to start at 4 and go to 10. So either one of those are valid ways of doing it. And you could, if you wanted to get, if you wanted to be deliberately obscure or something, you could come up with some other ways to do it. It might make sense to say I starts at 1 and goes to, well, if you started I at 1, then this number down here is going to be I plus 3, and the thing on top is going to be I plus 2. But then where would you stop? You'd have to stop at here where I plus 2 would be 9, so stop at 7. Yeah, so you could do something like that as well if you wanted to, but that's kind of silly. It makes the most sense to do one of these two here. So anyway, that should be enough on sigma notation for you to be able to do the stuff we're going to do in Chapter 5. The main stuff we're going to do in Chapter 5 is going to be adding up the areas of a bunch of different rectangles, and so we're going to wind up adding up, a bunch of function values. But anyway, this should be enough to get you through Chapter 5.